Welcome back to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Proteum Machining, and this week I'm joined by Clive Murphy from Powerbrake. Welcome, Clive.
Thank you. Nice to be on the show.
Yeah, I appreciate you taking the time. So before we jump into your backstory, let's kind of get what does Powerbrake do, where are you guys located, where can they find you online, all the good stuff.
Okay, well, we manufacture high performance and race brake systems. Head office is in South Africa, Pretoria, South Africa, where the company was founded. We have an office now in the States, in North Carolina, run by my brother, and one in Switzerland, in Madrizio, which looks after Europe, Middle East, Asia. We look after South America from here because one of our directors speaks fluent Spanish, and Australia as well from South Africa. So in a nutshell, we've sort of super specialized in 4x4 brake upgrades over the last while, and possibly we can get into that in during the story. But originally started out in circuits and high performance cars, and yeah, the road has sort of led us to off-road racing, and 4x4 was a really focused specialization.
Awesome. And then you're at Clive Murphy Powerbrake, is that right? Or Brakeman on Instagram.
Yeah, so Instagram is clivemurphy.brakeman, and then web is powerbrakeglobal.com.
Awesome. Well, to anybody listening who's not following you, head over, give him a follow, check out his pictures while we talk about him. So how did you get into, I guess, manufacturing brakes, manufacturing in general? What's your origin story?
Yeah, so in the late 90s, I was working for a company that was in the brake game, but less specialized. Brake hoses, to be specific, and brake hardware, the kind of clips and springs you find in calipers and would use in a pad replacement job. The company was actually owned by my father, and he and my brother still run that business. So in the late 90s, we started getting into high performance parts. We were bringing in a line of high performance brake parts from a European company. Sort of early 2000s, the local currency here took quite a hit against the European currencies. And we decided to give it a shot and start developing a line of high performance discs. So we're doing that under the brand name Powerbrake, and it became clear after a while that the two focuses were different. And as a family, we sat down and I said, look, I'd like to run with the high performance side of things. And they carried on with the rest of the business. So the family has remained close all these years. It actually turns out my brother now lives in North Carolina and runs the Powerbrake USA office. But yeah, so headed off in my own direction in that space. At that time, there were a lot of companies manufacturing what we could refer to as high performance rotors, and there were a lot doing high performance and race brake pads or friction materials, but very few were doing a lot of dyno testing with different disc slot patterns and different friction materials. So we set out from the beginning. I decided that it was something we wanted to focus on. And in those early years, we literally spent years renting time on a very high-tech brake dyno and just testing combinations of slot patterns and just about every high-performance and race pad that we could find on the world market. And it immediately became clear that there was a serious correlation between the two. So we were quite surprised at the time, to be honest, that leading names in the industry weren't doing this kind of research. So we were distributors for some of the high performance and race pads on the world markets. We started manufacturing a line of slotted discs. And in those early days, we came up with a matched kit, which a lot of competitors do now. But back in 2004, it was fairly unique. So we would interview a customer, whether he was track daying, using his vehicle on the streets, etc. And we would put together a bespoke kit for him with a rotor and pad combination that would work for his vehicle, his application. So that's where it all started out, grew quite quickly. Later, we added 4x4 vehicles and trucks, which was another interesting part of the story. Back then, it was quite difficult to find high-performance brake pads for 4x4 applications. So most of the manufacturers were sort of making them in fairly commercial grade materials. And the 4x4 community in South Africa is massive. So a lot of overlanding and a lot of guys just building up sort of sport trucks, if you like. So we worked with a lot of the pad manufacturers we were sourcing from at that time, and came up with the kind of friction materials you would expect to find on a high-performance German sedan, but had them manufactured in the various 4x4 profiles. Came up with specific slot patterns for 4x4, which helped in water crossings, mud, heavy sand, etc. And again, launched the matched kit concept. And again, it was a great success for us in our domestic market. Back then, we did no manufacturing in-house. So essentially, we were a design house, a lot of brake experience in the company, and we were outsourcing all of our machining. I am at my home office, so please excuse if you hear dogs. It's that time of the evening where everybody's walking a dog.
Oh, yeah.
So let's hope that the noise cancelling on the mic is working. Anyway, so we were outsourcing all of our machining, and it really allowed us to get a step up. We were really a small company at that stage, 3 people. And so, yeah, it was an interesting time of our lives that we were sort of driving truckloads of castings back and forth to a subcontract machining facility on a daily basis, and so it grew. Fast forward to about 2008, and we decided we wanted to launch a big brake kit. So I'm sure most of your listeners are aware, but a big brake kit essentially removes typically the front, but sometimes the front and rear calipers and rotors from the vehicle, and you replace them with multi-piston, usually lightweight components with some sort of race heritage, more advanced discs with more advanced cooling vanes, etc., etc. So it was extremely expensive to import big brake kits into South Africa at the time against the dollar or the euro, and yet South Africa has always had a really strong automotive street tuning, track day, motorsport type community. So we set out. I designed our first caliper at the time. Looking back now, we wanted to deliver something that was solid in terms of engineering, but fairly cost effective. And we totally over engineered the first caliper, which became a bit of a theme and a lesson that we had to learn as we went along. So at the time, it had separate pad per piston technology, the kind of stuff you find on a Bugatti Veyron now. So in 2008, sort of fairly unheard of. And yeah, we once again used a fairly high-tech shop that did a lot of sort of military and aerospace work at the time to outsource the machining. Late 2008, we were at a circuit testing. It was meant to be a private test, and BMW Motorsport was the only other people at the circuit that day. So they were quite strong in a series called Super Production Cars in South Africa. So essentially based on a 3 Series, but really powerful, quick cars. And they came walking over and sort of said to us, what is this brake system that you're running? So we said, look, it's not launched yet at all. It's in the early test phases. So, can't talk to you about it at this stage. So they said, well, we're having issues with a European product that we're running currently. Audi was their huge competitor at the time in the series, and they were doing a lot better under braking. So they said to us, look, we'd like to buy a set and test them. So once again, said to them, listen, absolutely not. We are not nearly at that stage. But there we go. And they just didn't stop pushing. So a couple of weeks later, we actually asked them to sign a contract saying that they're welcome to buy a set and test it. But, they would keep it to themselves and test it in private, as we hadn't even signed off and launched yet. Anyway, the test went really well. They had a kit fitted to a car 3 weeks later. And there was a great improvement. So the second car in the team went on to them. And it was the start of a long relationship with the team who, we eventually helped to win that championship. And braking was a large part of that success. So weirdly, we generally in this game, companies, new players in the market will sort of start in street tuning and then sort of dip their toes in motorsport and try and venture into that part of the arena. So the next year in the series, Mazda Motorsport moved to us, Nissan Motorsport moved to us, Ford Motorsport moved to us. So it was a crazy year in 2009, and we basically hadn't sold a kit to a street tuner yet, and we were ended up supplying the sort of top series in our country.
Wow.
So we always joke about how we got the dog by the tail on that one, but it just kind of happened. Anyway, so the first generation big brake kits, again, were a great success for us. We continued with outsourced manufacturing. So we would uh, outsource machining after anodizing. All QC inspection, assembly, etc., and the final sign off of the kits would happen in house. As you can imagine, in our game, the level of QC is extreme, and things have to be carefully documented. You can also imagine that liability insurance is a massive overhead for us. So in about 2015, we got to a point where the company we were using for the machining was just not keeping up. And it's one of those things, you're extremely focused on what you do, and they've got 50 other customers. So it started becoming problematic. We were starting to export at that stage as well. And, the fact that we're based 8,000 miles from many of our big markets doesn't help. It's already a lead time problem. So really the machining and delays in the machining were a real problem for us. So none of us had ever touched a CNC machine. So in late 2015, we decided, well, maybe we should look at bringing the manufacturing in-house. Started talking to some suppliers. South Africa traditionally has quite a strong CNC manufacturing base and support structure. So most of the brands are available, some not. And we asked around in the industry. Of course, budget was tight for us at that time. So Haas had done really well in the country, and a lot of people said their spares availability and the local HFO's backup is particularly good. And eventually we decided to go that way. So we thought, let's get a 3-axis machine. We'll put it in, sort of cut our teeth on that, and we knew we had to get into 5-axis for the caliper production. So late 2015, the 3-axis went in. I must say I'll never forget standing in front of that machine for the first time, knowing literally nothing. And fortunately, they had a great applications guy, Frank, still good friends to this day. And he was really patient with us and kind of stood there while we cut our teeth. And then 2 weeks later, Haas phoned us up and said, look, they've got a cancelled order on a UMC 750 that was being brought into Cape Town for an aerospace contract. And would we like the machine? So, yeah, cut a long story short, 4 weeks after we got our 3-axis, we got our first 5-axis. Never forget
goodness.
the day that arrived on a truck. I literally stood there looking at this thing going, I have no idea how I'm going to make parts on this thing. So possibly we should pause there. When we started looking into, we used to design using SolidWorks. And when we started looking into CAM software, Mastercam was quite popular in the country. But when we got the first quote, it was, and possibly just South African pricing, but it was really exorbitantly priced for the 5-axis software we needed at the time for a company our size. So started doing some research, and Fusion was sort of in its infancy at that point, but read about it and found a couple of online sources and gave them a ring in the States and said, look, we want to look at this. And it wasn't, as far as we know, nobody was using it in our country at the time. And they actually flew 3 staff members out from Europe, I believe, to come see us. So we were quite shocked at the service there. And we had a long chat, and they said, look, for what you guys want to do, we don't think it's quite ready yet. So they put us on Inventor with HSM. I think it was called Ultimate at the time. And we ran that for a year, programmed the 3-axis and the UMC 750 with that, and then shifted to Fusion a year later. And I must say, we've always had a great relationship with the guys at Autodesk that we deal with. From the early days, Tim Paul and a couple of others really helpful. The true Croatian sensation has been another great help. So yeah, we cut our teeth on Fusion, and we've kind of grown with it. So if we fast forward where we are today, in terms of software, we do everything from our design through FEA, recently into generative design as well, through to CAM, etc. And I must say, I know the opinions are divided out there, but I personally think in terms of value for money, it is an incredible product.
Definitely. Yeah, and your newest caliper, the S6L, that was generatively designed, right? In Fusion.
Yeah, so that we wanted to get into a generative project, but with very specific criteria. So, of course, as designers, it's great to go and build a highly optimized, ultra lightweight. Uh, Everybody likes a project like that, but really, we have learned over the years, and we'll get back to that. Be very clear on what your design objectives are when you start. Otherwise, everyone wants to make a Formula One caliper, right? But to take it to market, you've got to sell it.
Right.
So, yeah, maybe let's get back to the story, and we'll come back to the generative sort of where it fits in. So,
Yeah, definitely.
yeah, grew from there. Added a lathe to do all of our turn parts. Again, went with Haas with an ST15. And then at one point, we got a really nice contract from a US customer and needed to move quickly. And the one thing about being far away from where machines are built is generally 5-axis in South Africa is not big enough that the importers will carry stock of 5-axis machines. So it's literally a 3 to 4 month lead time from when you place an order. So we suddenly needed capacity, and Doosan had a 5-axis in stock, and unfortunately only with 30 tools, which has been a bit of a thorn in our side ever since. We definitely need more. But yeah, we got our D&M 350, put it down, FANUC control. Still fight with that to this day. Coming from a Haas control, the FANUC is just, it feels very 80s DOS computer to me. But a very solid machine. Really, the way that machine is built, it's a tank. And from day one has never given us a day's issues. And really, what do we really do at a control other than setting tools and so on? So it's all done offline anyway. So yeah, the Doosan was a great addition. Moved on, launched our second generation product with our new in-house manufacturing in 2016. That went really nicely for us. Exported it well around the world. Sold many thousands of those systems. And yeah, then literally late 2019, we started looking at the generative product. Yeah, so just being very disciplined, and it was a really interesting process. The software is very user-friendly, in my opinion. Picked it up really quickly. And then once you've done your various studies and iterations, and you've sort of zoomed in on a design that you like, you can export as a solid. You can also export as a wireframe. I actually decided not to. I found we specifically wanted to machine the product with positional and not get into heavy 3D surfacing. Just again, because of the cost, we wanted to bring it to the market at. So the workflow I used was the final design I literally had up on a screen next to me, and then traditional parametric CAD literally designed it around that so that I would have more control parametrically later. And I wanted to stay away from 3D surfaces. So yeah.
Oh, interesting.
So in the end, we actually have a presentation that we do to our customers where we overlay the two, and you can clearly see, it comes from the generative study, but we can machine it at a cost that makes sense for our marketing strategy. So then, interesting in generative, really what makes the studies great is working within a certain safety factor. You can really play with mass versus strength and rigidity. And it's quite amazing. You can go very light, but you do, in the materials we use, start to give up some rigidity. And yeah, we weren't trying to go ultra lightweight with our new third generation product. Lightweight on a crossover application, which gets you street and track, on street can lead to higher levels of noise, vibration, harshness. So, the lighter and stiffer you go, the more you're going to fight with that sort of thing. So on a dedicated race caliper, sure. On something that you want to be a crossover product that you can use street, track day, or race, you have to have some mass. Otherwise, with all the uprights on cars getting lighter and lighter, you start to fight with noise and vibration. So yeah, it was an interesting process, and in fact, I'm busy working on the 4-piston rear for that range at the moment, using the same generative workflow, and it's great. I think a lot of people are possibly nervous of generative because of the cost of manufacture. Whether you additive or subtractive manufacturing, if you fully optimize, it's expensive. But to anybody looking out there, don't be. Use the generative to learn where strength needs to be, and then manufacture in a way that makes sense for your product. And that's really what we did.
That's super cool. Yeah, that's a very interesting use case of generative that I don't think we see very often. Like you said, most people go to the nth degree and it's, some crazy organic shape that can either not be manufactured by a mill or, by only the highest end 5-axis. So that's a really cool lesson to be learned.
Yeah.
Uh,
I'd really recommend anybody who manufactures a product out there where strength, rigidity, lightweight, play with generative, regardless of whether you think you can afford to manufacture it. You can always dial it back, but what you will learn about where strength needs to be is fascinating.
yeah, that's super cool. So your current machine lineup then is the UMC 750, the ST15, the Doosan, and then you just added a UMC 500 recently too, right?
Yeah. And I see you've got some questions about that.
I
Um,
could not believe the amount of questions that I got specifically on that machine.
yeah. So the so we needed another machine by the end of 2019. We actually went with a microdynamics first, a new product to South Africa, well supported. Put the machine down, and sadly, a month or two after we put it down, we got a contract where we had to design a caliper larger than the machine's travel. So that was really a bit of a sad case.
Oh
So
no.
that moved on, and the UMC 500 was fairly new, I think, at the time. And yeah, it had the right travels and, of course, familiarity of control, et cetera, for our operators. So we placed an order. Unfortunately, then COVID hit, and it actually arrived in country we had a 5-week hard lockdown at the time. So a bit of a stressful time. But yeah, it went in, and for the first few weeks, we were making parts. We'd pre-programmed the new product for it, and we were making parts within days of it hitting the floor, and it was great for the first few weeks. And I will say there's a lot about the machine I like. The ergonomics, the visibility into the machine, and it cuts really nicely for a machine of its price point and size. Unfortunately, we did run into a number of issues after that. And again, the HFO in South Africa really, as per their reputation, those guys were fantastic. They were in and out of our shop for 6 months,
Oh
but
wow.
would not let things rest until all was sorted. So the machine, as it stands now, is cutting good parts for us. We spec'd it fairly highly. We got 50 tools, which was great. Where we've moved with the machining, we went from our first 5-axis having to do all of our calipers, all of the support components, the mounting brackets, etc. And as you can imagine, it was just a nightmare in setup changes and retooling of machines all the time. We've now fortunately grown to a point where we have dedicated machines. It literally, the difference it made to us was day and night. So our machines, the way they are tooled now, the original 750 is our support component machine, and the tool library never changes. We only change a tool if it's worn or broken. So ease of quick setup changes and programming is just fantastic. And we've done the same with the Doosan. The Doosan is basically dedicated to our 4x4 line, which is a high volume product for us. And then the UMC does all the slightly more specialized stuff. So our Dakar rally calipers, some of which are really complex and require a lot of tools, and the new generative line, again, which require a lot more tools. So yeah, I must say the way it's panned out is good.
Yeah, so that gets into a few of the questions that we did get from my audience. Is NS Precision asked, would you still recommend the UMC 500? Split 141 was asking about your thoughts, which you kind of shared. So, in retrospect, now looking back on it, is this another machine you'd buy? Like if you needed another one, I don't know, in another couple months, would you buy another 500 or would you be looking elsewhere?
Well, we are actually in that decision making process now. So I'm literally tussling with that exact question. I think I would buy another one. The machine really, for the price point, cuts beautifully. I think anybody who watches my profile can see the sort of surface finishes we get out of it. And I think you need to understand what you're getting. You're not getting a high level German or Japanese machine, but for for the price point, I think it's a great machine. If somebody from Haas was listening, I feel that sometimes Haas releases new products to the market possibly a little quickly. And bear in mind, the game we come from, we test things brutally before we release them. In our game, if you make a mistake, somebody dies. Um, sure, if a CNC machine doesn't work, nobody dies, but people's livelihoods are on the line. And for small companies, downtime it's a real problem. So all of the problems we had with ours, honestly, could be related to QC during the build process. And once fixed, the machine mechanically cuts great. So if anyone was listening from Haas, I would just say to them, possibly a little bit more due diligence on the in-house testing and QC prior to release. It seems that sometimes machines settle, they learn in the market, and I'm not sure I agree with that principle.
Yeah, no, I think that's the common thread that I hear through everybody who's had one or has one, is that it's not perfect, and it really could have taken another, I don't know, 6 months getting fully baked before releasing it to the public.
Yeah, for sure. So that actually brings me back to an interesting thing that happened in our company. When we brought our manufacturing in-house, we suddenly had this amazing ability. We were a bunch of designers who could now make anything. And being that our market is fairly small, we got a lot of different requests. So importing brake systems was expensive, and everybody from track day enthusiasts to oval track to off-road racing were all coming to us and asking us to design and deliver specialty systems for them. And we did, and it was a mistake in retrospect. And possibly any other small business owners out there, we got too diverse. We were manufacturing 14 different caliper styles. And bear in mind that we do each of them in up to 6 different piston ratios and different disc sizes, different finishes, etc., etc. So the amount of SKUs made it almost impossible to carry inventory. And we became a bespoke brake system manufacturer and really got ourselves into a very difficult time in the company's history, where lead times were pushing out 6 weeks, 8 weeks in some cases, upsetting customers, extremely stressful for ourselves. And at some point, I just decided we have to make a change. And you guys did the goal recently as a book. I was fortunate enough to study under Dr. Eliyahu Goldratt when I was younger. And we did a whole analysis using his analysis tools. And it was clear we had to focus the company. So it sounds like odd. I guess we were in a niche, but really too diverse. So we made a massive directional change in early 2019 at an annual sales conference with all of my staff and our overseas guys. I said to them, we're going to change the direction of the company completely. And we are going to focus very specifically on off-road racing, 4x4, and everything in between, and get out of circuit and high-performance street. So as you can imagine, there were a lot of very concerned people around the table. Sales guys, of course, feel the more arrows they have in their quiver, the more chance they have to sell a product. But really, for our company, it was important. At the time, a book I can really recommend to any small business owner out there is called Focus, The Future of Your Business Depends on It by Al Ries. Very easy read. And for any small business owner, honestly, have a read through it. So we narrowed our focus massively, and it really has been the best decision we ever made. Globally now, we're exporting our 4x4 kits to 25 countries from a small company. We employ 14 people.
Wow, that's really impressive. That's
what focus can do for you. And really, even the journey we've been on with this whole refocusing of the business, if you focus like a laser beam, you will be seen as a leader. You will often focus to a point where you almost pop out a new industry subsegment, if you specialize enough, and you can lead that subsegment. It's difficult though, Dylan. As a business owner, we feel it's safe to have one egg in 10 baskets, in each of 10 baskets. And in fact, it's safer, in my opinion, to have all your eggs in one basket. You must just pick the basket very carefully. So I'd rather spend my time worrying about did I pick the right basket than trying to chase 10 different baskets, especially as a small company. So, yeah, the difficult part of that process is telling the customer base that you're leaving behind, especially in a small market like ours, where they're going to struggle. And it takes a lot of discipline. There are some interesting ways to get around that, which include possibly spinning off a new, different brand to look after a different segment. The key then, make sure that the team that looks after the other segment only focuses on that, so that you don't tear your resource in people, machining, etc. Apart, or even try and sell it off if possible. So I've enjoyed watching in the Insta Machinist community. There's so many examples of this, whether they did it knowingly or not. But everybody from Grimsmo, who started out with car parts and he was a bit all over the place, and eventually found his focus. And for a large part of his great success story, essentially made one product. That's focus. And focused on CNC machining of knives, which I guess at the time was fairly different. Not many were. Area 419, John, again, a great story. He's super focused in terms of, in precision rifle shooting, he had all the latest reloading kits, and he decided, I'm going to build the ultimate reloading press on the planet. And I'm sure a lot of people told him, that's too specialized. But in my opinion, the more you specialize, the more things just seem to go well. So if you look at how that's gone for him, that product, it's been a great story to see, and that's super focus. Jay Gates with his razors, focusing on a very small niche within a niche, and it really seems to be going well. And even if you're a service provider like yourselves at Prodium, again, look at the community. Say a guy like Danny Rudolph, super focused on a very specific type of machining. He's always going to be busy because he's seen as an absolute expert in that market segment. So I believe in it, and a great book to read for any small business owner out there.
Yeah, I'll definitely have to give that a read. That sounds great. And I kind of was speaking to AJ about that on our Purple Cow episode, is that I have started to narrow my focus to specific types of prototyping. I know what customers I do well with. I know what kind of parts I do well with. And I'm starting to see those benefits that you're talking about. Being laser focused definitely has helped me turn away work that's, this isn't what I do. This isn't what we excel in. And really, it makes my customers happy because I have lower lead times and I know what to do. And it makes these potential customers happy because they go to the right people for it. So I totally understand.
Yeah, there's no doubt those two books do dovetail really well. I think the focus kind of gets you focused in a direction or a product or a service, and Purple Cow is really a great way at explaining how you need to tell the world what your focus is.
Definitely. So I want to jump back real quick. You mentioned you studied under Eliyahu Goldratt. How did that all happen? What's the story there?
Yeah, so that was crazy. I left school, and my father at the time was the managing director of an exhaust manufacturing company called Bosel. Started in South Africa and eventually went global. And the owner and founder of the company discovered Goldratt's work and went on one of his courses. He used to do a course in those days called a Jonah course. It was a 2-week course where you would go and do an analysis of your entire company under his supervision or his instructors, using what he called the thinking processes, which he kind of alludes to at the end of the book, but they really turned that into an art form. So essentially, the basic process was he would get everyone in management in a company into a room and just get them to moan about the things that they are unhappy about. And all of that would get written down. And then you would work back in a very logical cause and effect process to what he called a core problem. And his theory was a company always has a core problem, like a Herbie or a bottleneck in a production line. This is just looking at the whole company, not just manufacturing. And it's usually a very difficult problem to solve. If it was easy, you would have done it. So you get this problem, and it's linked very clearly in cause and effect to all these negatives that everybody threw on the table. He then had a very clever method of solving these difficult problems called a cloud, which he covers in a later book, I think, called It's Not Luck. Quite a powerful tool to break conflicts or core problems. And then you had to build up a future reality tree, again with cause and effect, proving that by solving this problem, you would in fact get all the desirable outcomes. And you had to check for negative branches, other core problems or other bottlenecks that would arise from implementing your solutions. So it was a 2-week process. And basically, when you left, your management team had a real strategy moving forward. So the owner of this company put all of his directors internationally on it. So my dad went on the course. And at the time, Dr. Goldratt really had an interest in educating teenagers to think. He was a real character. I'll tell you some anecdotal stories about it. And what he would do is he had an office in America, New Hampshire area, and once a year he would get a whole bunch of his instructors to come over, and anybody who'd been on a Jonah course globally, as long as they could send their teenage kid to the event, it was for free. And you got to study under these guys for 2-3 weeks. So my brother and I went at the age of about 18, 19. And spent the 2 weeks over there. It was really fascinating. I think there were about 120 teenagers from all over the world. And he really was an incredibly intelligent guy, a really no BS guy. I heard Ellie say things to people in talks where he didn't pull any punches. If you thought you were being stupid, you got told. And it was just pure logic. And he was hard to argue with. So it went well. I then attended a number of his conferences back in South Africa, and we actually got to know each other. And he eventually actually offered me a job in the States, a sort of internship for 6 months. And at the time, with what was happening in the family business, I turned it down. But yeah, I've got a lot of great memories of sitting after hours in a pub having a drink with him. And yeah, he was a real character and highly intelligent.
That is so cool. I mean, reading his book now twice, you kind of think about him as this larger than life character. So it's really great to meet somebody who has studied so closely with him.
Yeah. And I must say, subconsciously or consciously, I've used what I learned my whole career. If you look at our factory setup, we are constantly monitoring in his process for bottlenecks and how to elevate them. And even the way we run our accounting in our company, he had a very different way of looking at cost accounting, and we've always run it that way, and it works for us.
Wow. How cool. So you had mentioned school. I had a question from White Weasel about being self-taught in CAM. So what did you go to school for? How did you kind of get into all this design work in CAM and all that stuff?
So I didn't study engineering, which is often a laughing point in our company. I studied information sciences, which was a really cool degree at the time. Now, bear in mind, this was 1994, so internet practically didn't exist. And it was a course about, the whole degree went about how information will be the most powerful currency in the world in the not too distant future. And a really fascinating course. The guy who put the course together was also an interesting guy. And really, if you look at the way the world's turned out today, he was exactly correct. So I did nothing mechanical at university. I was one of those kids, like so many of your other guests, who played with RC cars, was always very mechanically minded, building motorcycles, etc. And when I got into the brake business, I just became fascinated at how you can transform the way a vehicle reacts with these parts. So in our company, we have a standing saying. We talk about live and dead parts, very simply. So we see anything that's a live part as something that will significantly change the experience of your vehicle when you drive it. So, of course, tires, shock absorbers or suspension, brakes, etc. And we see dead parts as something like an oil filter. I'm sure the oil filter guys won't be happy. I'm sure there's a lot of technology in it, but you can put the best or the worst oil filter you want on your car. And let's face it, when you drive it next, it doesn't feel different. So we've been fascinated with chassis dynamics and just how much you can change a driving experience with brakes. And yeah, it's a passion that just went.
Okay. So in designing your first caliper, where did you go? How did you start learning SolidWorks and design philosophy for brakes?
So really self-taught. I had a really good friend who was a qualified mechanical engineer. We used to spend a lot of time together in the early days. Now, as the company has developed, I have an extremely good team. Our technical director was with Ford and for 12 years and with Toyota for 4. And we've got a bunch of great engineering brains in the company now. Yet I still design the calipers. They are involved in a bunch of other projects. Disc design, which is really quite advanced these days with airflow and cooling, and all the adaptation type products. You can imagine every time we make a caliper mounting bracket, the level of FEA and so on that goes into it is quite extreme.
Definitely. Yeah. So actually, it dovetails perfectly. Fort Manufacturing asked, how do you guys get the information on mounting bolt patterns and clearances and all that? Like, are you renting and 3D scanning? Are you getting data from manufacturers? What's going on there?
We use a CMM, a portable coordinate measuring arm. We've actually found, we experimented with scanning, and we actually find that a touch probe system works better for us. The scanning, it's a lot of data, it's noisy, and really what we need is if you really want to break it down, planes and circles. So yeah, we've got a Roma arm. I think Hexagon Metrology might have bought Roma since, and it's been a great piece of kit for us. We cart it all over the country, often flying around to measure new platforms. And yeah, we build it up from there.
Awesome. So do you have partnerships with manufacturers that loan you cars, or are you going to future customers and scanning or measuring their cars? How does that work?
Yeah, so getting cars quick is obviously the challenge. Manufacturers are not really keen to be lending out brand new models in most situations. So generally, it's a case of trying to find a customer that has a new model, is keen on the brake system, and usually we will cut him a good deal on the first system. So after design, of course, we like to do first fit, and really by then all the components are extremely well tested. What you do have to take into account, though, of course, is it's not a case of a caliper is a caliper. So we developed our own in-house brake simulation software over a period of about 10 years, and it's an absolutely key part of our business. So once measuring, of course, the guys will start modeling up the vehicle's uprights and so on. But the key parts are there's about 18 different variables in terms of the rest of the brake system. So rear caliper piston ratios, master cylinder, wheelbase, rolling radius of wheels, CG height, etc., that we have to plug in. And then using the software, we will specify the piston ratio that we select for the caliper that we're going to use. So it's all about balancing the brakes hydraulically as well as with friction materials, and basically balancing the brake torque. What you'll generally find, for interest's sake, is a manufacturer will tend to, let's say the perfect brake torque bias was 70% front, 30% rear on a specific vehicle. They'll tend to release the car at about 75-25. The theory being your front pads are likely to wear out first. And what if the customer goes and puts in a really low friction pad from the local spare store into his high performance car? They can't have a situation where there's too much rear bias, which is far more difficult to deal with than front. So on race cars, we balance them on a knife's edge to the point where we will sit in the pits. And if they drop the rear ride out by 3 mils, we will change on the balance bar what we want. But on street cars, you've got to be a little more conservative.
That totally makes sense. That's really cool that you guys developed your own software for that as well. So let's get into tooling, because like you said earlier, you guys demonstrate super high levels of finishing on all your brakes. And White Weasel asks, what's your favorite tools? Do you use Big Daishowa in the UMC? You guys, I'm not sure about your Doosan, but the Haas's clearly aren't Big Plus or anything like that. So but let's dive into tooling. What's your favorite manufacturer? What's your go-to? What are some end mills that you can't live without? Stuff like that.
Yeah, so in terms of tooling, we've really, our first factory, which is now full, our first unit has been really an experimental melting pot for us to really learn what we're going to put in the next building. We started with Sandvik holders exclusively on the UMC 750, a lot of their hydraulics, and honestly, a great product. And I do find that in terms of harmonic, probably they have an edge. I believe that the hydraulic fluid in the holder has some damping properties for sure. So that was great. We decided on the Doosan, since it was a Big Plus, to talk to Big Daishowa. We felt go talk to the company that came up with the concept of Big Plus, and service was great. We actually dealt with them directly in Japan, put the whole tooling set together, and great holders. Little more complex to work with, just in terms of all the spanners and collets, etc., which definitely the Sandvik hydraulic, in terms of quick and easy to use, it's hard to beat. But again, great surface finishes with the Big Plus. I personally have found our product forces us to use some pretty long stickouts in terms of gauge length. And the Big Plus combination with a really high quality holder is so rigid that I find sometimes on long stickouts we actually get more harmonic in the tool than we do with our hydraulics. So that was an interesting learning curve, but got it all dialed in, and feeds and speeds are great, and they really do work in terms of accuracy. Then in terms of the UMC 750, just to really throw a spanner in the works, we decided to tool the whole machine with Nikon to compare. I wanted to see the two Japanese companies performing against each other. There are some holders, though, that only Big Shower makes. They make some extremely skinny pencil holders, and we have to drill next to some extremely close to some vertical walls, and we've never found anything else to beat the Big Shower on that. Again, with their tapping holders, which I believe is a license agreement with somebody, I'm not sure which company, they do some very skinny stemmed tapping holders, whereas the Sandvik holders, etc., are far more bulky, and we have to tap very close to vertical walls. So we've kind of learned along the way. Next machines would be a mix, depending on what tool and what we need to use it for.
Okay, and then what about end mills and solid tooling? What's your go-to manufacturer, or are you also bouncing around and finding what's best?
So in terms of end mills, we use a range from Tegutech. It's 3-flute, 45 degree. And we've just found on 40 taper machines that recipe, 45 degree helix, 3-flute in the aluminum that we machine from, is unbeatable. The specific range of end mills has always given us exceptional finishes. It's well supported in our market, so we've stuck with that. In terms of roughing, we've walked an interesting journey there. A lot of our competitors globally start with a forging or a casting. So, of course, there's a higher tooling cost up front, but then in terms of machining, we're giving up all of our roughing to them. We've always liked to stay with billet. We feel the design freedom it gives us is good. But we really, the first 7-8 minutes of every one of our cycles, we've pushed hard to get material off as quick as we could. So we spent many years using trochoidal milling. But even with chip splitters, we found eventually chip control or getting chips out of the building was becoming a major problem to us. We were filling massive drums in an hour per machine. So we've actually ended up using insert cutters. We currently use a 63mm ISCAR 3-flute in a very interesting holder from Nikon, which actually has a split in the taper of the cone and I must do a post on this, a reverse angle which the pull stud pulls on internally. So it really guarantees you the most surface area contact between your spindle taper and the tool. So again, we have to use this insert cutter at quite long gauge lengths. And we've got the roughing to around about the exact same time we used to with trochoidal, but the chip density, we get 3 times the mass per bin. So it literally has it's slowed down our problem of moving chips out by 3 times.
Wow, that's insane. And I think you've mentioned that holder at some point because I looked it up. I remember looking that up, but that's a really interesting. It kind of mirrors, I guess, what happens with dual contact, where they're trying to deform the cone, but they're forcing that with those splits. So that's a
so Nikon call dual contact or Big Plus 2-lock, and then they call this holder 3-lock. So you're obviously still getting the face and taper, but they're claiming that in many situations, people are getting a lot less surface area contact between the spindle taper and the tool taper than they think they are. And by putting a split in it, they're saying you get a lot more surface area contact. And I can only tell you at the gauge length we use this tool, and we've run that ISCAR at 10,000 RPM and 6 meters feed. It's dead stable. Yeah, the paint doesn't last long on the inside of your machine.
That is crazy. So I guess any other lessons learned that you can share with us about, long gauge length tooling, or, I mean, tapping or drilling next to walls. It sounds like you guys have a lot of very interesting design problems that you need to work around with tooling.
I think the biggest piece of advice I would give is just spend on your holders. I understand possibly in a job shopping environment it's difficult, but I just believe that by buying quality holders of whichever brand you prefer. I mean, there's so much out there with other brands, Rego, etc., etc. But I just feel that if you want to reduce the hassle, make quality parts first time, and not spend time remaking and struggling. We've always just felt from day one we'd like to invest in the holders, and it will pay for itself down the line.
And then as far as 5-axis programming and in general, what lessons can you share as a self-taught 5-axis programmer? What have you encountered, especially on these popular machines, UMC 750, UMC 500, limitations or things you've had to program around that you found work really well?
Firstly, I've got to be honest. I really think the heroes of the machining world are you guys in the subcontract or job shop environment. Really, what we get to do is fairly easy because you get to really refine a specific product. Of course, there are all the caliper adaptation brackets and stuff. There's new and interesting things coming up every day. We've just done a Ferrari kit which required some really strange bracketry. But I honestly think that the real master machinists out there all come out of the subcontract environment where you guys are facing a different challenge every single day. So hats off to you. In terms of what we've had to learn to do, secretively, I would love to, and it may well happen in future, get my hands on a really high level Japanese or German machine and just see if it's really much easier to achieve what the surface finishes that we would like to have. And let's be honest, there are some very critical tolerances on a brake caliper in terms of piston bores and so on. But in terms of the surface finish, we often take very expensive products out of Europe and look at the surface finishes externally, and they're terrible. It's not required for function. We just always felt that when somebody takes your product out of a box, it says something about your company, the way it presents. So, yeah, I think I drive my staff crazy with insisting on surface finishes and so on. Fortunately, I don't do all the programming anymore. I do calipers and all the support components, lathe work, and other 5-axis work on bracketry. One of our other directors, who's a really intelligent guy, has picked it up in a year, and he's running the rest of the factory.
That's great. So let's talk about tool life then and how you guys manage that, because to achieve these great finishes, you clearly have to be monitoring all that stuff. What kind of in-process inspection and tool life management do you guys use?
Yeah, so we use the basic tool life management at the control. The Haas version is fairly simple. You have feed time, so that gives you an idea of cutting time and deployments. So yeah, we monitor on a new machine from the day we put tools in, and then we'll just set warnings. So when we feel that surface finishes are going, we will set up from there on that machine, and that's it. When we get to sort of 90% of expected life, we change tools. We get surprisingly good tool life. Now, maybe that's attributed to the holders, as we spoke. Generally speaking, and we're not cutting titaniums, and we do a bit of stainless, quite a bit actually, in terms of some stainless parts that are used in the calipers. Specifically on our lathe, we machine a pretty tough stainless called Maxival, made by a company called Valbruna. And really the tolerances we chase with that lathe, when we bought the lathe, and I told a friend of mine in the industry who works at a big shop that runs Japanese machinery, the tolerances we wanted to try and keep on these pistons, he just laughed at me. He said, "You'll never do it on a Haas." So we try and keep the variance on piston production under 10 micron across a whole day's production. And we do have to comp quite a bit, but we've really got the process dialed, and we achieve it day in and day out. Possibly it would be less work on a far heavier, more expensive machine, but we do it. So the RA values that we're chasing, we get straight off the lathe. We do polish still on pistons because it affects seal life, but it's a very brief polish that we do, and that sort of takes it to almost a mirror finish.
Wow, that's impressive. So what kind of in-process inspection do you guys do on calipers and pistons? Do you have a shop floor CMM that you're putting things on, manual checks? What kind of things do you do?
No, so on a caliper, your checks are actually very basic. So we have a clear policy. In the factory, we are not doing quality control for safety. We are purely doing for not making bad parts. And then engineering upstairs does all the final safety sign-offs and so on. So down on the factory level, basically on a caliper, there's a couple of planes you need to measure, and you can do that very easily with mics quite quickly. And we use pistol grip bore mics, again, just to keep caliper bores within spec. And then upstairs in engineering, they are obviously using CMMs and so on and so forth. But really, we don't want to confuse it. Engineering has the sign off. In the factory, we are literally ensuring that we don't make bad parts.
That's a really good distinction to make, definitely. So, as far as the tolerances on the piston bores on the machine, are you interpolating those or boring those?
No, so we don't bore. A lot of people are surprised with that, but we literally just 2D contour them, and we've got the process and the holder dialed to a point where we comfortably keep it within range in terms of roundness and in terms of size. So
Wow, that's great.
it's a machine tool pocket problem. We would take up 12 different pockets if we were boring, and we didn't have the space. So we couldn't do it. And there's no way we're going to stop and change a tool to bore different size pistons. Generally our cycle times, even on our most complex calipers, we're trying to keep under 30 minutes. And yeah, it's just we didn't have the tool pocket. So again, and we're doing this not on top end Japanese or German machines. And if you see the traces in terms of both ovality and size, we're really doing well. And again, that's attributing to tools and holders.
Wow, that's really cool. So, what about engineering sign off? Do you guys have what kind of final inspection do you guys do on calipers?
So that gets kind of interesting. Each caliper literally ends up with a passport of about 14 pages, all critical dimensions signed by two people, documented scanned to the cloud. We obviously have to keep records very carefully. In this game, liability insurance is very difficult. So you go to any insurer and tell them, I want global liability, not restricted to countries or regions, for high performance and race brake parts, and you're in for a learning curve. So our insurance company works very closely with us. They have every process in the entire manufacturing and QC step. And if we make a change, we have to clear it with them. The day there's a problem, if changes have been made and not cleared or shared, it's problematic. So, yeah, fortunately, we've got a great guy, the engineer I spoke to you about, our technical director. He is our QC expert. He put the whole system together. And yeah, it's painful. There's no doubt about it. But again, we constantly tell our staff, we cannot have a bad day. We can't make mistakes.
That's a really interesting viewpoint because I deal with a similar style frozen process in aerospace, but it's customer imposed, not insurance imposed. So it's interesting to hear that style of frozen process exists across all kinds of different industry segments.
In fairness, they didn't get involved in wanting certain things in the process. The process was in place by us. They looked at it, were happy, but if you make changes, they want to know. So, they weren't involved in the actual design of the process, if I can put it that way.
Right. No, that's more or less what we deal with as well on aerospace, is that as long as the part comes out good and is approved good, they're happy with the process, but then it is locked down and there are no changes unless it's go through the approval process. So that's really interesting to hear, but it totally makes sense. I mean, if they're giving you more or less unlimited liability across the world, that's quite a big undertaking kind of thing.
Yeah, look, there's no unlimited liability. There are obviously max values, but all carefully calculated. And yeah, it's especially when you start selling in countries like the US, Australia, where litigation is also picking up quite massively now. It's expensive, but you got to do it. And it's, we take our QC very seriously, and touch wood, we have never in the history of the company had any form of failure. Generally, if there are complaints, it'll be like a vibration on a disc, and 100% it's generally fitment. So we do, for example, 100% inspection on Swiss equipment on runout and disc thickness variation on every disc assembly, the two-piece disc assemblies. We generally hit an industry average about twice the norm in terms of tightness of tolerance. And the problem is a customer will go out and he'll have a rust scale on his hub and he'll just put the disc assembly on it. So yeah, your fitment instructions, again, we literally turned our fitment instructions into an art form to try and get people to read them, or at least the key stuff.
Right. Yeah. That definitely makes sense. That's unfortunate that you guys have to, but I've definitely seen people put parts on cars and not think about things like, oh yeah, I should probably touch up my mounting surfaces so that they are actually flat. So it definitely makes sense.
So again, Fusion's great there. We generally, the first page of every document, which is vehicle specific, we have a nice exploded view of the entire brake system with all the key torque values, and just so that the guy can visually see the bracket fits this way. We find that people just don't want to read these days. So you've got to give them a quick visual with the key safety and fitment data. And again, Fusion makes that easy.
Totally. So that kind of wraps up the questions I had, but let's get into what's new in your shop. You said you guys are starting to look for a new machine. So what's in the running for that? Another UMC, you said possibly. What else are you looking at?
Yeah, it's been an interesting process. So I believe we need to get into lights out automated machining for the future, where our plans are going. We believe at our current growth rate, we have capacity for about another 6 months before we hit an issue. But as I said to you, we have to start planning about 4 months before we need the capacity. So I believe lights out is important in our future. The transport of our kits to the big markets, which is a long way away from us, eats into our profitability. And we want to try and claw that back by running lights out. Having said that, going back to the goal, you really need to plan this kind of thing carefully, because you kill a company quickly by looking at local efficiencies. So sure, the lights out caliper machining cell will make a lot of product, but you have to balance the flow of the whole line. So it's a case of going, what other machines are going to be repurposed if we put in an automated cell like that? So certainly some of our caliper machines would have to be repurposed to support componentry, etc. Otherwise, you're just going to create massive bottlenecks and increase inventory, and it's bad for your company. There's a big debate going on internally at the moment between myself and Francois, the other guy involved in our production process. He has done studies where he feels that it may be better for us to buy, you can more or less buy 4 mid-level 5-axis machines, so think Doosan, Haas, there are some other options, and put them back to back in 2 cells. So one guy generally runs 2 machines in our factory, sometimes 3, but we find 2 is the right number, and run them in a day shift, a manned day shift. So 4 machines, 2 operators, back to back op 1s and 2s. Our op 1 and 2 cycles both have 5-axis, and they're both similar cycle times. And he feels we'd get similar throughput, and we would have 4 spindles, which gives us redundancy. The lights out cell, if you go for something that will work lights out, and that's maybe worth just talking about for a second, it's similar money to 4 UMC 500s. If you go for 40 pallets, sure, it will work lights out. In his opinion, you have 1 spindle. Anything goes down on the machine, your production stops dead. So it's a valid argument both ways. The one thing we have learned over our day shift running is if someone is planning on getting into lights out, there's a lot you have to consider. The UMC, we have to constantly sweep chips to the conveyor. They build up on the wall where your door would be to a pallet pool, to a point where I must post some photos. We're really churning through aluminium. So if you're going to go lights out, it really has to be a machine where chip control is well looked after, coolant flow, probably high pressure wash down on walls. Otherwise, you're just going to run into issues. So in that case, he might have a point. It might be better to have more spindles and run a day shift. It's a big debate within the company at the moment.
So what machine are you looking at, or what machines are you looking at if you do go pallet pool? Are you talking like an Akuma, or what brand, I guess, are you looking at?
So for sport in our market, DMG, we've had a look at DMG Mori. Something that would typically work well would be a DMU 50 with a PH cell with 40 pellets. There are some other ways within their range to do that. We've had a look at Kitamura Supercell. It's another option, and then a Doosan DVF 5000. Doosan now do a 40 pallet tower as well.
Oh wow, I didn't realize they did that. I knew
Yeah.
they had a smaller pallet pool, but I didn't realize they had something that large.
So essentially, that pallet pool just in more levels. So they've quoted on that as well. So those are the three that we're kind of seriously looking at the moment.
Okay, and then how would you solve the bottleneck? Because I assume, and I could be completely wrong, but I assume the bottleneck right now is inspection and final inspection. I mean, it sounds like there's a astronomical amount of paperwork that goes, along with every pair of calipers.
Yeah, so look, the bottlenecks are constantly moving. Up until recently, it was assembly. We were finding that inventory was piling up before assembly. So we put in a resource there. Of course, it takes some months to train. That's all up and running well, and it's smoothed out that bottleneck. So yeah, now you start doing exactly what Ellie says. You start seeing where in your process inventory starts piling up, and you just start attacking the next bottleneck. For sure, if you consider that a lights out cell on a half an hour production production cycle time, 40 pellets would get us 20 hours. So yeah, in terms of flow down the process, other machines would mean repurposed. We'd need another lathe at the same time as the cell, and for sure more assemblers. So again, Francois' argument is, but if you go for 4 machines, you can do this in stages. In terms of financial input, capex outlay, and in terms of balancing your process or your flow. If you put a big machine like that down, your natural tendency at the monthly payment or the capital amount invested is going to be to want to run it. And bear in mind, you can kill yourself with overdoing a local efficiency like that. So there he may have a point. The multiple machine model you can do in stages.
Okay, yeah, I definitely see the benefit of his plan as well. Yeah, because it would be very attractive to say, well, I've got 20 hours of production time. Let's spend the next few weeks just running 20 hours and loading pallets. So, but then, like you said, you'd have parts stacking up in assembly and all that. So, yeah, it's definitely an interesting argument.
For sure, for sure.
So what else is going new? You guys just released a new caliper, so I'm sure you're getting all those made and prepped and shipped and all that stuff. What else is going new?
Yeah, so we do a lot of private label work, and essentially, if we go back to the focus thing, with our own brand in export markets, we're really focusing on the 4x4 side of things. We do supply a number of private label products to leading brands in various spheres. So what we try to do is partner with kind of the leader in VAG tuning, the leader in BMW tuning, and so on and so on, Z cars, etc. So it's no secret. They open about it themselves. We make the entire brake line for APR. Their sister company, Dynon, we are talking to at the moment. And we have a couple of processes like that. So at the moment, some interesting new developments for private label customers. And yeah, I tend to do all of my prototyping on Saturdays when I can think. It's really busy in the week. So Saturday is kind of my quiet time in the factory. We do sometimes or quite regularly run a half-day shift on a Saturday. But a Saturday afternoon, you'll usually find me prototyping, proving out new programs, etc.
Oh, fun. Yeah, I definitely understand that not being able to do thoughtful work like that during the week. At my day job, we work 4 10s, and so whenever I have a chance to work a Friday, it's very quiet and I get a lot done compared to the week.
It's amazing, again, what you can do without interruption.
Definitely.
And then other than that, we do a lot of on-car testing. So my own driving sort of spent a lot of time on circuit in my life. And now with the off-road thing, I drive a Raptor and we really push hard. So generally, weekends we spend out testing. We're busy running through a very interesting tire test at the moment. Of course, essentially, we just slow a wheel. Ultimately, the stopping distance will always be determined by the grip between the tire and the road surface. So especially in the 4x4 realm, there's such a spectrum of tires from highway terrains, all terrains, mud terrains. And we're running a 1 year test now where every 4 weeks we're testing a different tire. We can supply multiple brake pad compounds, of course, for our kits, and we literally want to get it to a point where a customer tells us what tire he's running, his vehicle weight, his application, and we can make a very qualified recommendation on how strong we can go. You don't want to overbrake a car. That's just as bad as underbraking it. So we have a standard tire test series that we're going through. So I've been doing a lot of driving. There's some really nice rally training school not too far from us. So we do a lot of high-speed gravel and mud pools and so on there. And then obviously wet and dry tar as well.
That sounds like a really fun part of the job, for sure.
I must say we've always enjoyed it. We joke and say you can't work at Powerbrake unless you love driving. So everyone there can put in a decent lap time. And yeah, I feel for my wife. She gets to hold on a lot on weekends.
Oh, wow. Well, very cool. I always wrap up the episodes asking my guests, what are you researching this week? It doesn't have to be machining related. It's just always really interesting to hear what other peers in the machining community are looking into.
Recently, we've been doing quite a bit with 3D printing, which we have never used in the company before. We're investigating the possibility of whether we could print. Some of the brake hoses come with really complex bracketry. The German and Japanese cars tend to be far simpler, just one mid-mount, usually on a fork on the shock, but it's an important component. It keeps the braided brake line away from the inside of the tire. Some of the US manufacturers have a very different approach, very complex steel bracketry. And you know, if you're doing what we do is fairly low volume, even in our what we say are our high volume movers. You're going to do a couple of hundred kits a year. So to really go and invest in making tooling to bend these brackets, we want to see if we can 3D print them. So a new young engineer in the company, Keegan, has been diving into it deep, experimenting with various different materials. And we've set up long-term whip tests. So we've built a little test bench which we can whip a brake hose around about 1 million cycles. And we're running these 3D printed brackets through this to see if they can take the long-term fatigue.
How cool. So yeah, I remember you posted asking for recommendations. Did you guys decide on a printer, and what did you decide on and why, if so?
So everyone seemed to come back and really speak highly of the Prusa. Unfortunately, when we looked into it, there's just no support in our market for them. So we went on recommendation with a Creality CR6, I believe. And I must say, certainly in this early phase, it's been doing very well. The prints are coming out great. I must say, the young engineer whose project it is was really into 3D printing before this. So he got the right project. And so far, the stuff's looking great. It's printed with our logo, part numbers, and we're experimenting with a whole different bunch of designs and fail safes. So we're trying to design that if for some reason it were to break through fatigue, there's a fail safe that still won't let the hose near the tire.
Very cool. Yeah, that's quite it sounds like step out of your normal day-to-day design and all that. So it must be a fun challenge.
Yeah, so I walked up into engineering the other day, and I'm really fussy about the way our places look. So engineering looks like an operating theater. And there was a cardboard box bent on the white bench where the 3D printer was. And I almost had a heart attack. I said to our technical director, what is going on here? We bring people through for tours regularly, almost daily. This looks like something out of a garbage bin. And he said, no, the climate control, the air conditioning unit was blowing too directly at the 3D printer and it was affecting Keegan's prints. So he needed a screen. So I said to him, this has to change immediately. So the next day, I must actually post a picture of it. He had constructed an extremely modern looking screen on our laser, branded with hinges that he 3D printed, bases that he 3D printed. So you walk through now and it looks like a glass surround. And he even put an LED strip in the bottom with our red company coloring so that it sort of glows red around the 3D printer. So I was like, I'm getting old for sure.
Oh, that's great. So before we wrap up, you said you had a few Goldratt stories. Are there any that stand out in your mind as really interesting or funny or anything you want to share before we wrap up?
Wow, there were so many. So in all of these conferences, what would typically happen is people from different companies would stand up and explain their story that they had used the techniques to do, and there were just so many good ones over the years. In terms of Eli himself, so in the book he describes Jonah. In the book is obviously Eli. The character was fashioned on himself. So as they describe him, he always wore black pants, an open collar white shirt with open neck, and his yarmulke. And I never saw him wear anything else. He used to smoke Cuban cigars. And towards the end of his career, a number of big talks he was doing out in South Africa, the venues would start saying to him, "You can't smoke in this venue. It's a closed venue with 400 people in an auditorium." And he would just straight tell them, "Good, then I'm not doing the talk." So, and that was it. If you didn't let him smoke his Cuban cigars, he didn't present. So it was funny. I remember one specific talk that he did at PricewaterhouseCoopers, which is a big accounting firm in South Africa. So there are 400 chartered accountants sitting in front of him, and he had a very different way of looking at how you cost products in a production company. So generally, traditional cost accounting, the bean counters in the company will start breaking down the cost of the person in front of the machine for the cycle time, the coolant, the electricity, wear and tear on the machine. And I mean, you can drive yourself insane with that stuff. And Eli was of the strong opinion that you don't do that because it confuses whether labor is seen as an asset or a cost. So he had a very simple system. Your inventory was anything you had bought that would be used, that you would make into a saleable product. Everything else was seen as an operating expense, and that included anything you invested money in that would help turn the raw material into inventory. So all of your staff, labor costs, your machine costs, everything went into a simple another tank. And it simplifies accounting to a really easy to deal with situation. And he was busy presenting this to these accountants, but essentially he's busy telling them that what they studied is far too complex. So they got really upset with him, and he just told the one guy, "You're an idiot. You are a flat out idiot. You cannot argue with what I'm saying. Your system is complex, and you should leave the room."
Wow.
So it sounds harsh, but he was a really clever guy, and he didn't suffer fools easily, which you can kind of hear in the book. Quite short, as the character was in the book. When he felt you were asking questions that you needed to go think about, he told you so.
You can't put a price on that kind of learning, and it sounds like it's really served you well in your company and taking it into the future. So that's pretty amazing.
So I have a question for you, if you don't mind.
Of course.
I've been yakking on for too long. Do you think you'll ever launch a product, or are you going to stay in the service space?
I think we will definitely launch a product at some point. I'm not sure at what size, or it might be some simple little doodad, or we've talked about, I've 3D printed some collet storage things, and I might sell those. I think both Brad and I really want to just go through the process of creating a product, pricing it, packaging it, shipping it, and get that under our belt so that we understand how that works. So that when we do come up with an idea that we think is worth pursuing, it's not this big insurmountable step of like, oh no, now we need to figure out all of this stuff. So we've talked about for quite a few years doing a Kickstarter or just a pre-sale or something small so that we can get all of that managed, and that so when we do have a good idea, we can knock that out of the park.
It's going to be great to watch. I really enjoy watching that process, and it's one of the things that I've enjoyed so much about the Instant Machinist community is just watching that process happen so many times. It's great to see, and I really think we live in a world today that never before has it been that accessible to design, simulate, manufacture, and get a product to market. And I do think whoever the guy was at Autodesk who felt that there must be a more cost-effective way to do that, and it can't just be the domain of big corporates. Hats off to him. it's great to watch how many people are bringing products to market, and to companies like Tormac and Pocket NC and even Haas with their toolroom products. It really makes it accessible. And I mean, there's so many beautiful stories of guys who have started in their basements or garages and have done really well in a short space of time.
Oh yeah, yeah, I totally agree. I think now more than ever, finding your niche and finding that audience for the niche is so easy. Never before could you sell, you know, Kelvin at Urban Survival Gear. He makes pens, and like never before could you establish a business so quickly on such a niche item and grow like he has. Or Grimsmo, or any of these people that we talk about. They really have capitalized on how easy information is to share.
So it's going to be great. I look forward to watching which basket you pick, and and seeing you hopefully focus hard on it.
Definitely. Well, again, thank you so much for your time. I appreciate you coming on. I love, watching and following you on Instagram, and so it's been great to get to talk to you.
It's been great. Thank you very much. It's been an honor. I've been listening for a long time, and thanks for the work you guys are doing as well. Great to listen to all the stories.
Well, thanks everyone for listening, and we'll see you next week.